Check this out. VK3 VKE testing on this frequency. So that's the RF meter at the moment on maximum sensitivity, okay? And I'll do a quick demo.
Menu.
TX power is set to low. Now I'm going to have to zoom in for you. I'm actually into the hallway, okay? But I'll just zoom in and then key up again. Yeah. I'd like to show you how to make this really simple field strength meter that's active, runs on a battery, using readily available components. You get a bunch of these little boards for next to nothing. But check this out, right? I will show every detail and a schematic soon, and I'll try and keep it short and simple. But first of all, over here, I've got my IC705, and you can see there's a wire coming up to that ant on the wall there. And across here, you can see there's a light flashing. That's one of my current detectors. That's another experiment hanging off. I'm doing a charging experiment. And then it comes across to that ant on the ceiling, and then across here, and just to literally to the hinge of the door, and then hanging down to a reel. So I've got it tuned with the homemade Transmatch, a magnetic tuning system. So, because of course it's not a 40-meter antenna, that's a random bit of wire across the room. So, so there's a few components. It's very, very simple, cheap to make, but I'll quickly demonstrate. So I'll go over to the antenna where the light is over there with it on full and come back, and then I'll do it on minimum. So, right, so you see it already full now. I'll go right up to it, so now I'm only inches from it. Now I'll turn it down to absolute minimum and see how quick it drops off. Wait for it to start. There we go. We've dropped off fully. It will come back a bit here because I'm sort of close to the other end of the antenna, sort of. Oh no, okay, not here, of course, only on maximum. That's on minimum. So there we go. Alright, so there we go. And minimum. And turning it up. So you're getting closer to this corner over here. It's getting hot again, right? But moving away. But yeah, I'm only running 10 watts, so it's fantastic. So, for HF, you have to hold one element. If you were using it only for HF, simply only have one element. Follow the configuration rules though, because where the other element would be, you just have to have a metallic contact, because you become part of the antenna. As you see the difference when I let go versus hold one element. So for HF, it's much more important for you to hold one element or have a contact that you touch. But I've got two elements on it because I want to use it for VHF. And these two telescopic whips here are the right length when both extended to be a half-wave dipole at 2 meters. And also when they're collapsed down, they're very close to the right length as a half-wave dipole for 70 centimeters. So keep in mind when you're selecting the telescopic elements that you want them, especially for VHF and UHF, you want to be able to have them at the right lengths, adjustable for the bands of your choice, assuming for amateur radio 2 and 70, or 63 centimeters for Australian UHF CB. But like I said, for HF, you need to hold one side. You don't even need the element, just something that contacts to that part of the circuit. And you could, of course, go for a longer element for the top if you wanted. That would improve it. But so that's fantastic. So yeah, if you look inside the system, I'll turn that down. You can. I've done this to make it easier for the video. You can see I've got two copper rails, okay? And you might notice, it's hard to see, I've got one with a red positive on it and one with a negative, so positive and negative. So for the rectification side of things, each antenna goes to two germanium diodes there, 1N60P, that's 1 November 60 Papa, in a push-pull. So this element connects to two diodes. One diode is directed for current flow to the positive, and the other is directed for current to flow from the negative. So to the positive, from the negative, and both linked to the antenna. And we have the identical scenario at the far end up here. I have the antenna connecting to two diodes, positive, with the direction to the positive rail on one and from the negative rail on the other. I will show a schematic soon. So you don't even need a capacitor across this. And I also then tap the positive and negative rails. I'm doing one from each end, so I've got, I can't quite see this. Let me see. On the positive, see the yellow wire down here, I'm tapping the positive via the 100K potentiometer, okay? Which I'm adjusting now, as you can see. So going via the potentiometer, so I can adjust the amount of this rectified DC that's getting to the sensor unit. And the negative is just going direct to the sensor unit. And you can see here, so we've got the yellow, this is the positive for the sensor, the negative for the sensor. The negative cannot be coupled to the negative for the battery supply. The wires on this plug are the wrong way around, color-wise. That red is actually the negative, and the black beside it is the positive. It's just the way the plugs came, because I couldn't, I bought some to put together myself, but it was too fiddly for me. So, yeah, so ignore that, you'll figure that out. So, and it's pretty simple. So I've got the battery at the back. Its pins go through here, and they connect essentially to the input, except one is broken via the switch. So that's pretty simple there. So I'll just show the little board here, and as you can see, those 4 pins at the top right, I'll put this down. We have those 4 pins. So this one says VCC, so this is your positive from the battery. The next one along is your negative from the battery. Do not couple the negative from the battery with the negative for the source, the sensing side. So then we've got the negative for the sensing and the positive for the sensing, and that's where your rectified side goes in via the potentiometer. And of course this side is your DC supply side via the switch. Leave this potentiometer at max. If you don't want to add a potentiometer, you could just adjust this, but these don't last too long for too many adjustments. So leave this at maximum and adjust the DC to the sensing side via 100K potentiometer. Extremely simple. So I'll hold the other side. See, I'll show you the difference when I touch that element. So for HF, it's critical. I will show a schematic soon, and then I'll do a VHF demonstration. But I think you'll really like this. These things, you can get 5 of them or whatever on eBay, super cheap. The germanium diodes are inexpensive. A bunch of little switches are inexpensive. The potentiometers are inexpensive. I think I've got one somewhere here, but anyway. So yeah, it's a great little gizmo. So I'll show a schematic, and then I'll do a VHF demo. And remember to click like and 7.3. Okay, and now for the schematic. Forgive my dodgy drawing. So centered around the little board, very inexpensive. We have the 4 terminals like mentioned earlier. So from right to left, we've got the positive for the power supply, then the negative for the power supply, then the negative for the sensing source, and then the positive for the sensing from our little rectification system. So make sure, like I said earlier, don't tether the 2 negatives. It will blow the chip, apparently. I don't want to try it. So the positive on the right hand side here goes via your switch to the positive of the 9-volt battery, and your next one along, the negative, goes straight to the negative of the battery. So that's simple as anything. Now, I will jump straight to the antennas and work backwards. We have the antenna up here and the antenna down here. Each antenna has 2 diodes. They're 1N60P germanium diodes. So notice this one has its arrow in the direction of the positive rail. So it can push current into the positive rail, but it can only pull current from the negative rail. Okay, and current is supposedly opposite to what they call electrons. So in other words, positive charge goes here and positive charge goes from here, which makes this more negative. As you can see, we've got positive and negative. And we have the exact same thing from the other antenna, where we have one of the diodes with direction towards the positive and one with the direction from the negative. Okay, so we tap the two rails. The positive tap, not connecting to the antenna here, jumping over, is going to a potentiometer. So it's basically a variable resistor. And then we take that output from there to the sensing input positive at the far end, the left terminal. And the negative rail is connected straight over to the negative. Sorry about moving this around. I'll move that out of the way now. Of the input. And remember, do not connect these two negatives. So that's it. It's extremely simple. Stay tuned, because I'll do a cool VHF demo. Check this out. VK3 VKE testing on this frequency. So that's the RF meter. At the moment on maximum sensitivity, okay, and I'll do a quick demo. Menu. TX power is set to low, okay. Now I'll just transmit and I'll wander away. The good thing about this, probably better with your eyes than the camera, but it's quite high vis into the distance. I am on low power, okay. Now just bear with me. I'm not going to go any closer, but I'm going to zoom so that you can see it. Okay. Okay, I'll transmit again. And it's back up again. So that was some reflections, obviously cancelling, the signal and stuff. There we go. Still very full. And I'm dropping off now. And I'm actually all this way away over in my hallway. Okay. So that is absolutely mental. I'll zoom back, and I'll just go closer actually. And okay, so we're here, and you can see polarization issue and a match, polarization issue and a match. So that's low power. Now let me change that to high power. Confirm. Okay, and wander away. Oops, bumping into things here. Now I'm going to have to zoom in for you. I'm actually into the hallway, okay, but I'll just zoom in and then key up again. Yeah. So that's actually, in the hallway. I'm actually beside, I'll zoom out, hang on. There we go. That's my cupboard there in the hallway. So absolutely amazing. So yeah, definitely worthwhile building one. If you want to reduce the sensitivity further, of course you could add a higher value pot. But if you shorten the antenna elements and detune from the exact band you're on, it will also significantly reduce sensitivity. I'll show you what I mean. I'll just shorten this one quite a bit, right? Let's shorten it significantly so it's obvious. You can do all this yourself when you build one. So now it's still decent element lengths, but let's see what happens, right? I'm making sure I've got it set at maximum, and this one is set at high. Okay, and well, yeah, close up. Very good. I am on high, but already dropping significantly. Allow me to zoom for you. It might come back. Yeah, now see, I'm going further and further, and nothing, and that's on high. So an easy way to desensitize it is adjust your element length as well. So that is absolutely phantasmalogic. I'll just stretch out these elements again. Bear with me. Okay. Put it back in place. Oops, showing you the dog's chicken necks. She loves them. All right. Yeah, so there you go. Make one. They're bloody easy, and yeah, bloody's not a swear word in Australia. All right, 7 to 8, and thanks for watching. This is Crazy Ham.